Welcome, everyone. Thank you so much for joining us today for the webinar with Netcom Learning. My name is Jennifer Crumpton, and I'm going to be your host today. Our webinar topic this afternoon is how big data changes the way decisions are made. Big data, as you know, is the big buzzword right now for cutting-edge business strategies in the information economy. It's the future of organizational success and social impact, so learning how to approach it is critical. Collected data is more than doubling every 2 years, creating a whole new world of both opportunity and challenges. Our distinguished keynote presenter today is Vincent Suppa. He's an NYU graduate professor and the CEO of HR with business literacy in finance, strategy, and technology. He's an efficiency expert with operational experience in high-tech, telecom, healthcare, nonprofit, and government sectors. He's the former founder of SHRM, the chapter president, and a Sarter TV speaker. Today's session is being recorded, so you will get free access to the recording in the next 24 hours, and it'll come via email. A PDF of today's slides are in the questions pane. So if you want to keep them to refer back to, you can click on that link. I just pasted the link into the questions pane for you to download. In case this is your first time joining us, I'd like to direct your attention to the dashboard view for all of our webinar attendees. Just so you know, everyone's been muted except for our presenters. But we do want to hear from you, so if you have questions, please type them in the questions pane. We will address all of your questions at the end of the webinar. You'll also have the option to adjust the window size to your liking. If you want to do that, just simply hit the Escape key and find the Zoom button on the top left corner of your GoToWebinar viewer. And now, I'd like to hand the floor over to Vincent. Vincent, I am going to make you the presenter, and you're on.
Thank you, Jennifer, and good afternoon, everyone. I'm very happy to be here. So the next 18 minutes, we'd like to give you the least you need to know about big data. Now, the definition of big data, it's a broad term, and it's used to describe data sets that are so large and complex that traditional data processing applications are simply inadequate. Now, this webinar will comprise of 3 basic shifts that we will discuss about big data, from small to all, from clean to messy, and from causation to correlation. Now, as Jennifer mentioned before, data is doubling every couple of years. And if you look at the slide, we have noted that 15 years ago, 1/4 of the world's information was digital. 75% remained in analog. In 2014, 98% of the information was digital, and this is only growing. Now, let's talk about what big data is not, because lots of data existed before, quote-unquote, big data. This is big data. This is your definition. It is the ability to render aspects of life into data points never quantified before. So what was once only qualified, we are now able to quantify. So your new word of the day, this is datafication. Now let's discuss what datafication is, because datafication certainly existed even before computers were invented. And the example we'd like to give you is latitude and longitude. Before latitude and longitude became prominent in the world, people could only qualify their locations. Meet me beside the mountain, meet me underneath the tree. But with latitude, we could say, meet me 20 degrees latitude, 50 degrees longitude. So what was once qualified, we can now quantify location. This is a very basic example of datafication. Now, there was a Japanese scientist that even datafied body contour. What he did was he datafied how people sat down. He measured the pressure points of drivers sitting in their cars at 360 different points via sensors, each on a scale of 0 to 256. So datafication basically took what was once qualified, how someone sat down, and now it quantified it. And one of the applications that this manifested was an anti-theft device, because now sitting down became a personal signature. Now, what are the tools for datafication? I would like to call your attention to the first 4 tools of datafication: inexpensive computers, powerful processors, basic statistics, and clever software that can be purchased commercially. Now, these 4 tools are all commodities, but algorithms, that is the differentiator. Now, let's talk about lots of data versus quote-unquote big data. Previously in the past, computers were able to do translations from one language to another, but they did a poor job, and regardless of how powerful a computer was, it would basically be a dictionary, and each word would be translated to another word. And that's why a lot of the translations were awkward. But translations via big data, the way Google translates languages, is that they look at statistical probabilities on what the best word is. And the example was that if you were to feed years and years and years of Canadian parliamentary transcripts into a computer over many years, which are both in French and English, statistically we can now infer what the best word is to use. For example, the French word lumière would be a more appropriate substitute for the English word light than ledger, and big data could infer that statistical probability. Now, a quick review, and then we'll move on to our third shift. The first shift is small to all, where we went from sampling a population to now looking at the entire population. And again, this is made possible because of the tools of datafication that we mentioned in the previous slide. The second shift is pristine data to non-curated, messy data. What that means is that when you are sampling a large population, one bad data sample could throw off your conclusion, because one sample might represent 100,000 voters, let's say, if we're trying to statistically sample a polling station. But with big data, because we're going from small to all, meaning we're now measuring the entire population, we are easily able to tolerate messy data. Now, one of the most important shifts of big data is that we move from causation to correlation, and this is how businesses are setting themselves up. So reasons on how the world works is now replaced with learning about association among phenomena. Now, knowing cause is desirable, but cause is harder to figure out. And of course, there is cognitive bias, and some scientists will say that causation is partly an illusion because there always tends to be a step in between what we merely perceive as cause and effect. Now, we're going to give several examples of this. Saving trucks. There's a trucking company that placed sensors on parts to identify heat and vibrational patterns associated with failures leading to breakdowns. And then they simply collected the data. So we are looking at historical data. So after a year or so, they looked at which trucks broke down and what were the heat and vibrational patterns that had been datafied. So this trucking company is able to predict a breakdown before it happens and replace parts in the garage instead of on the side of the road. Now, in this example, data does not tell us why the truck is breaking down, but it reveals enough that we're able to associate certain vibrational and heat measurements on the car with the high confidence level that that truck is likely to break down perhaps in 3 or 4 weeks. So again, that part is replaced in the garage and not on the side of the road, and that is an example of reducing SGA cost, which will of course inflate net income. Now, there's an example with Canadian physicians that they monitored premature babies. They monitored their heart rate, respiration, blood oxygen levels, blood pressure, and after a couple of years, they examined which babies, premature babies, thrived and which ones unfortunately failed to thrive. And they collected over 1,000 data points a second. So what happened was, by collecting all of this data and now being able to correlate it to babies that thrived compared to babies that did not thrive, doctors in Canada were able to discover correlations between very minor changes and more serious problems. Now, of course, the underlying cause will be investigated, and is of great interest, but when you're saving lives, knowing what to do is more immediate than why something is happening. Now, this is one of my favorite examples. Big data predicts epidemics better than the Center of Disease Control. The CDC tracks patient visits to clinics, so the information suffers from about a 2-week reporting lag. Now, Google took 50 million most commonly searched terms between the period of 2003 and 2008 and then compared them against historical influenza data from the CDC. And then Google took the searches and they correlated them with the CDC's data on the outbreak of the flu. Now, the Google example demonstrates all three shifts, and we're going to discuss them now. From small to all, Google ran 100% of U.S. searches for 6 years through an algorithm. They did not sample the data, but they looked at the entire population of searches. They identified 45 searches that they ranked as having a high correlation against CDC data on flu outbreaks. Some of the searches that showed a high correlation were runny nose, body aches, etc. The second shift that the Google example represents is clean to messy, because the searches were imperfect, there were misspellings, incomplete phrases. In fact, it also included many healthy people that were perhaps searching the flu for loved ones that lived outside of their state. Now, the easiest example to illustrate is causation to correlation, because no one will ever claim that simply searching for flu symptoms in Google caused someone to have the flu. Nevertheless, it was highly correlated with people who did in fact have the flu. So what's interesting here is that big data, not medical scientists, were able to predict outbreaks real time compared to the CDC's traditional data analytics that lagged by over 2 weeks. Now, datafication turns all aspects of life into data. Again, what was once qualified is now quantified, and that is datafication, and that is the power of big data. Now, Google is developing these augmented reality glasses. They haven't completely taken off yet, but they do exist, and what Google has done is datify the gaze. Twitter datifies stray thoughts, and LinkedIn datifies professional networks. Again, these three examples previous to big data were only qualified. There's an example of an IBM technology where the floor of a store is one big giant iPad. It's called surface-based computing technology. And what stores are now able to do is datify customers' movements. They know what aisles they go down in what order, how long they linger in front of a certain product, and how quickly they may pass another product. They're also able to determine if anyone slips and falls. So an example of this is many stores, instead of having the surface-based computing technology, which can be expensive perhaps, certain stores will offer you coupons via a text message. And when you accept that coupon, what often happens is that you are allowing the store to use your smartphone as a GPS tracking device. So in effect, the store is able to monitor your movements. So again, they are datifying your browsing habits, and they're able to make smart decisions by determining what correlations they want to make. Now, we have an example with the former mayor of New York, Mayor Bloomberg. Now, Mayor Bloomberg made his money in data, in Bloomberg terminals, and he was faced with a situation of illegally subdivided buildings that are likely to catch fire, but only having 200 inspectors to respond to over 25,000 complaints a year. So what the mayor's office wanted to do is they wanted to see if big data could help them triage which complaints to visit first. So New York City created a database of almost 1 million buildings, and they augmented the data of those buildings with troves of data collected by over 19 agencies. They looked at variables such as tax liens, abnormal utility usage, service cuts, missed payments, ambulance visits, rota complaints, etc. So they're looking at buildings that had caught fire, and they're looking at the buildings that had not caught fire, and they're seeing which ones are correlated to which variables. So they looked at 5 years of building fires, they ranked them by severity, and they observed a correlation. Again, not a causation, but a correlation. So the data scientists were able to triage the complaints for inspection. And what they found was that of all the variables they looked at, only type and age were the main predictors of fire, the other variables proving superfluous. And they also found that buildings that had a permit for exterior brickwork correlated to a lower risk of fire. So as a result, vacate orders increased from 13 to 70% because now inspectors were only visiting the buildings that were correlated with an already higher risk of fire. So again, the building characteristics did not cause fire, but they were correlated with fire risk. And this is what businesses are doing today. Instead of figuring out why things are happening, they're using the power of datafication to figure out the correlation between something that they want to happen or avoid and what variables might be correlated to it. And then they're able to manipulate those variables. Now, what can you do in a world of big data? Well, you want to use data that you already collected. So one of the things that we can do, even tomorrow, is take an inventory of the data that your company is already collecting. Then in plain English, state the problem that you hope to solve. And then you could set up an independent and dependent variables and set up the hypothesis that you would like big data to solve. And then, of course, the fifth thing that you can do is there are many online courses that you can take on coding. But I want to call your attention that even if you are not quantitatively inclined or mathematically inclined, of the 5 things that you can do to get started, the first 4 that I mentioned are qualitative soft skills that you could immediately begin using, and then you can bring in coders when you're ready to take that step. Now, I call your attention to the Freedom of Information Act. It is a federal law in the U.S. that allows disclosure of previously unreleased information controlled by the U.S. government. Now, many people incorrectly think that this only applies to files, but it also applies to data. You are able to, under the Freedom of Information Act, to request troves and troves of database. An example would be the MTA has huge databases on their ridership, and this is how private citizens were able to develop apps for the MTA because they were able to access databases that were previously kept by the government. Now, I want to call our attention to the ubiquitous nature of data. Remember that Facebook accomplished what most democratic governments tried but failed to do, to build a database of its citizens. Now, what is the role of human beings in big data? Well, as big data becomes ubiquitous, what are the skill sets that mark points of differentiation so we could take advantage of them to help our own careers? Well, discovering latent needs and intuition that goes against the fact might be a distinguishing characteristic of human beings. And the ability to define a problem will always precede its solution. So those 2 comprise important roles that human beings would bring to the table. Now, big data has a quantitative and a qualitative side. And I'd like to mention the qualitative side because these are things that we can all begin doing immediately. Develop observational skills to separate the signal from the noise. Again, take inventory of existing data, learn how to develop hypotheses, and then learn the specific mechanisms on how to access external data from the Freedom of Information Act or from LinkedIn, from Yelp, from Twitter. How do you go about accessing external data and then correlate it with data that your company keeps internally through its ERP system perhaps? And then you can be the liaison between the internal data gatekeepers, the IT monitoring the ERP system within a company, and external data that you were able to access from the outside. And then you can always network with STEM grad students, science, technology, engineering, mathematics. You can always contract grad students and pay them as contractors as data scientists to help you develop the coding that you need to test a hypothesis for the correlation that you're interested in. So finally, big data does have its limits. If Ford queried big data to find out what customers wanted, and he invented the automobile, he would have come up with faster horses. So of course, big data is not strong to discover latent needs. So for innovation, that's always going to be a human trait. And in a big data world, traits that we can develop are creativity, intuition, curiosity, and of course, leveraging errors and risk-taking. If you are interested in attending big data events in New York City, you may check out the event page on hravg.com. Jennifer, thank you very much. I'm going to turn it over to you.
Thank you. Thank you, Vincent.
Yes, very welcome.
So please go ahead and send in your questions for Vincent. You can do it by typing them into the question panel to your right. Before we get to the questions, I'd like to briefly share some important information with you. As you see on the screen here, we have some really exciting topics coming up for our future webinars, and they are all free. So on May 7th, we'll give you strategies for effective meetings. Coming up on May 12th, we'll give you a quick tour of what's new in Microsoft Project. And on May 19th, we'll talk about ASP.NET validation controls. So you can just go to netcomlearning.com/webinars to check them out and to sign up. And just a reminder that you'll have free access to the recording of today's webinar. A link to it will be sent to you via email in the next 24 hours. You can also take a look at our world-class training courses here under the Courses tab. We have courses on a range of IT skills, software management, and soft skills. And we actually have a promotion that ends today on April 30th. So get it while you can. If you sign up today, you can get a $100 American Express gift card on any Microsoft technical class enrollment. And who couldn't use $100? So find out more about that at netcomlearning.com/education/specials. And this is really important for us to mention at Netcom Learning, and that's our learning movement. It promotes the values of lifelong learning around the world. We really want everyone to be able to know the power of learning. So every time you register for a course with us, we donate to give 1 year of education to a child in an impoverished area of the world. So if you're interested in finding out more about that, you can check that out at netcomlearning.com. So it looks like Vincent did an extraordinary job because at this point there are no questions for him. Oh, here we go. They're starting to come in. Vincent, how do you inventory the data that you have?
Sure. One of the first things that I recommend is that you sit down with your IT department, and they should be able to give you a list of all of the data definitions that they keep track of. Now, I realize many people still track data on disparate systems, on Excel spreadsheets and whatnot. So another way would be to send out an email blast to all the department heads, simply asking them what are all of the data points that you keep track of, and then to to cascade the list up. So in conclusion, you go to your IT department, ask them for a list of all the data definitions on their ERP system, and that should be simple enough to do. And alternatively, if people are tracking data offline, to send out an email blast to all department heads asking them not for the data points, but for the variables that they're tracking, and then to develop that list.
Vincent, the second part of that question is what do you capture and how do you store it?
Well, most data is already captured by a company's ERP system, resource enterprise planning. So companies have HR systems, payroll systems, they have customer relationship management systems, inventory systems. So you have software such as SAP, Oracle, JD Edwards, Workday. So most companies would already have systems, even if they're outsourcing their payroll, for example, they still own the data. So it would be very rare that a company doesn't keep track of a database. They need to track their customers, their revenues. They have general ledgers. They have accounts payable, accounts receivable, HR records.
Great. So one of our attendees says that in one of their classes they learned that big data was able to predict flu outbreaks, but later this failed as the people measuring this missed many statistical concepts that psychometricians know. So I don't know, Vincent, are you aware of how Google fixed this problem?
No, I'm not aware of the issue, and I'm definitely open to learning more. I will say that when you develop a hypothesis, an algorithm, you're constantly retweaking the algorithm. In the same way that Google constantly retweaks its own search algorithm, right? Because they look at historical results and they try to make the algorithm better. An algorithm is constantly being improved, but I cannot speak to the specificity of that example.
Okay. And can you talk a little bit more about why non-IT people need to learn coding, and in what scenarios do you see this skill being used?
Sure. I know in many grade schools we have younger children, third, fourth grade, that are learning coding because it's considered literacy. For example, when we were young, literacy was being able to write and read using the alphabet. But today's literacy for the children coming up, literacy means the ability to be able to code. So while you will not have to compete with other coders, you merely have to compete with other people in your profession. So understanding coding will give you the vocabulary, and actually it will enhance your professional esteem among coders when you have that conversation. I want to use a quick analogy. Two people are camping and a bear comes, and one camper jumps up and he starts to run, and the other camper says, "Why are you running? You can't outrun the bear." And the camper says, "I do not have to outrun the bear, I merely have to outrun you." So let's say you're in marketing and you're learning coding. Well, you're not competing against other coders, you're competing against other marketing people for those top jobs. So you don't have to be an expert, but a little will go a long way because it truly does represent the new literacy.
Yeah, good point. We have an attendee asking if you have a recommendation for free online courses on coding.
Yes, there are many available on Khan University. I believe, unlike Python, R code is free. There's lynda.com, which is not entirely free. There are many things available even on YouTube and whatnot. If you were to Google R, which is one code that I recommend, you will see many free courses. So in conclusion, Khan University might be one, and there's plenty of material available on YouTube.
Great. That's it for our questions today. If anybody has any additional questions that you think of later that you'd like to ask, please feel free to email us at webinar@netcomlearning.com. That's webinar@netcomlearning.com, and we'll be able to pick up your questions. So thanks so much for joining us at Netcom Learning today. I hope you got as much out of it as I did about big data, and we look forward to seeing you back here with us for future free webinars. And if you liked it, please tell a friend. The more the merrier. Thank you so much to Vincent, and have a great day, everyone.
Thank you, Jennifer.